A particular technique that is often combined with domain-driven design is called hexagonal architecture. Now, hexagonal architecture is not directly related to domain-driven design. You can use domain-driven design without using hexagonal architecture. However, it is very compatible with domain-driven design, and so you'll often see it used in conjunction with it. And you'll see in a lot of the literature around domain-driven design, you'll see this concept of hexagonal architecture coming up. So what is hexagonal architecture? It's also known as ports and adapters. So it was the idea of ports and adapters in the hexagonal architecture was proposed by a man named Alistair Cockburn. And basically, it's an alternative to the layered or N-tier architecture that you may or may not be familiar with. The N-tier architecture, if you're not familiar with it, is the idea that you separate your application into different layers, usually with a database layer at the bottom, and there's some kind of user interface layer at the top, with kind of a domain layer sandwiched somewhere in the middle. And the number of layers varies depending on who you talk to, but it's somewhere between 3 and 5 or 7 or something like that. And so the idea is, though, that you have the user interface on one end, the database on the other end, and a bunch of other layers in the middle, with the domain being one of the important ones. Hexagonal architecture takes sort of a different approach here. The idea here is that instead of the domain being in the middle of kind of that sandwich of the N-tier architecture, the domain is at the core of something that it more closely resembles, in this case, a hexagon, but in other drawings, you'll see it as an onion. So the idea here is that the domain is core. It is absolutely the most important thing in your application. Therefore, it should be at the center. What you have then is that you have ports that are exposed by the domain. These ports act as essentially an API. They are a preferred way of communicating with the domain. Then you have a series of what we'll call infrastructure adapters, and those adapters communicate with those ports. They communicate through that API. There's different sides to the hexagon. So on one side we have something like the sort of the user side API, and on the other side we have the data side API. Now, if we actually were to flip this around on its side, then what you'd see is the user side API at the top and the data side API at the bottom. And at that point, it starts to resemble the N-tier architecture. So in a lot of ways, it's just a different way of presenting the idea of the N-tier architecture. However, there are some additional rules that go along with hexagonal architecture that aren't necessarily talked about as much in the N-tier architecture, and those additional rules provide some benefit. So I mentioned before that one of the ways you'll sometimes see this drawn is as an onion. So here we've kind of combined the onion and the hexagon into a drawing, which again, you see the domain at the center. Now, outside of that domain, we have another layer, which is the API, sometimes called the services layer. I prefer to avoid the term services because service in domain-driven design means something very specific again. So I like the term API a little better, and I think it captures the meaning fairly well. So the domain exposes an API, which is another layer outside. And then outside of that, we have an infrastructure layer. So the idea here is, again, the domain is the center of the onion. The API provides the ports, and it's another layer. And then the infrastructure provides the adapters, which communicate with the ports. One of the keys here is the dependencies. The outer layers are allowed to depend on the inner layers, but the reverse is not true. So the infrastructure can depend on the API can depend on the domain, but the domain has no knowledge that the API or the infrastructure exist. This has very interesting consequences. What it does is it means that hexagonal architecture ensures a proper separation of infrastructure from domain. You can guarantee that the domain has no knowledge of the infrastructure. It doesn't know about the database. It doesn't know about the user interface. It doesn't know about any of those things because it's not allowed. Those rules prevent that. So it prevents the concerns about databases, user interfaces, things like that from bleeding into the domain. Now, this can be enforced with packages. So what I will often do in a project is I'll create a domain package, an infrastructure package, and an API package, and then I'll do searches and things like that to ensure that my domain package never refers to anything in my infrastructure package, for example. But you can also do this using project structure. If you set these up as projects with dependencies, then you can ensure that you can't have the API depend on the you can't have the domain depend on the API or the infrastructure, because you simply don't create that dependency. And if you did, it would create a circular dependency, and then it wouldn't compile anyway. And so what this does is it allows your domain to be portable. It means that it becomes much more easy to swap out pieces of your domain or pieces of your infrastructure rather, without having to affect your domain. So you can go ahead and swap to a different database implementation. It doesn't have to be a different database. It might just be a different table structure within the same database. But you can swap to different structures without having to affect the domain. The domain doesn't know that you're using SQL. It doesn't know that you're using Cassandra. So changing those things becomes irrelevant from a domain perspective. The other thing that it does is it allows you to make changes in the domain without affecting the API or the infrastructure potentially. So I've had situations where I've used this technique and I've realized that the way that we had done things in the domain was fundamentally flawed, and we went ahead and rewrote the entire domain of a particular microservice without having to change anything in the API or infrastructure. And so because you have this clean separation, it means that you can make these kinds of substitutions, and external clients of your application don't have to know about them. They don't know that anything has changed because you have this nice level of isolation. Systems designed around hexagonal architecture can therefore be very flexible. You can change them in a lot of different ways without and have a minimal impact on clients. And so that's a very powerful technique. Now, having said that, if you are comfortable with using end-tier architecture and you've been using it for years and you do a good job with it, feel free to continue to use that. But if maybe you have had some issues with end-tier architecture in the past, or if you are just looking for something new, or maybe you've never heard of end-tier architecture, I would recommend you take a look at hexagonal architecture in more depth. It does give you a lot of power and a lot of flexibility to change things in your system. Now, in terms of Akka and Logem, some of our reactive tools, they actually leverage hexagonal architecture very well. What they do is they take the concepts of hexagonal architecture and they abstract many of your infrastructure needs. So persistence, distribution, and communication are all built into the toolkits. Those are all infrastructure concerns. And they're built into the toolkits in such a way that in many cases you can swap them out using different plugins. What this means is that you can now focus on the domain rather than having to worry too much about the infrastructure. You can worry less about the persistence, the distribution, the communication, because those are all taken care of by the toolkits. And now you can just focus on building the domain, which is really, at the end of the day, what we're there to do anyway.